Hello everyone. So in this part of number system, we will be discussing the topic representation of irrational numbers on the number line. So to represent any irrational number on the number line, the first thing we should know is we will be using our Pythagoras theorem. So that is nothing but our hypotenuse theorem. So what is our basic hypotenuse theorem, or as Pythagoras theorem states? So it's nothing but hypotenuse square will be equal to base square plus perpendicular square. So using this particular condition of for a right angle triangle, we will be representing our irrational numbers on the number line. So let's see our first one. So that is nothing but our representation of root 2 on the number line. Right, so here we have to represent our root 2 on the number line. So as we know, root 2 is nothing but it's greater than 0. So it will obviously lie to the right side of our 0, which is nothing but our point 0. So it will be lying right side of it. Right. So our root 2 can be expressed in terms of according to our Pythagoras theorem. So root 2 can be written as root over 1 square plus 1 square, where base is 1, height is 1 and the hypotenuse is nothing but root 2. So now you can observe the figure here. So this is nothing but your number line. As we know, root 2 lies right side of our origin. So we are taking a base of 1 unit. So this is our base of 1 unit and a height of 1 unit, which is at point A. So after locating it, we know the hypotenuse OA is nothing but according to Pythagoras theorem root 2. Right. So now take your compass and then take O, that is 0, to be your center, and then take this distance OA. So OA to be your radius, and then mark an arc such that it cuts on our number line. So that particular point, so it cuts our number line at point B. That point B is nothing but the location or the representation of our root 2 on the number line. Right. So this is how we locate root 2. So similarly, let's see another one. So representation of root 3. So now our basic aim is we can actually express this root 2 in terms of our Pythagoras theorem. So root 3 can be written as root 2 square plus 1 square. Right. So we have to express in such a way that root 2 square plus 1 square, which is nothing but root 3. So now let us take our number line here. So if we take our number line, we know how to draw our root 2. So first we have to locate our root 2, as in we have taken or represented our root 3 in terms of root 2. So we have already located our root 2, which is at point B. Right. So now from point B, we have to drop a height, that is a perpendicular of 1 unit. So here our height will be equal to 1 unit and our base is nothing but equal to root 2 units. So this is our whole base root 2 and this is our height. So according to Pythagoras theorem, this radius OC is nothing but our root 2. So take a position at O and take OC to be radius, and then mark an arc such that it goes and touches the number line at point D, which is nothing but that is the location of the root 3 on the number line. Right. So the only basic thing is we should know how to write or do our any irrational number in terms of our Pythagoras theorem. So moving on to the next one. So representation of root 7 on the number line. So now here our aim is how we can write our root 7. So we can even write our root 7 as root 6 whole square plus 1 square. Right, we can write it as root 6 whole square plus 1 square, where we have to do all our root 6 until root 6 we have to find. Or else we can write that in another way, that is root 3 square plus 2 square. So this will be the easiest one, because if we once locate root 3, it will be easy, and 2 units we know how to find it. Right. So let's see the figure. So if you observe, we will be taking a 2 units. So this is from 0, 1 and 2. So here it will be our 2 units, and we know how to locate our root 3. We have already located our root 3 at point D. Right. So after locating our root 3 at point D, at our root 3 point, we have to construct a line, a perpendicular line of units 2, because here our height is 2, not 1. So here we have to construct a height of 2, where from 0 to here, which is nothing but root 3. So root 3 is our base, and then our height or perpendicular is nothing but our 2 units. Same way 2 units at point E. So our OE is nothing but again our required irrational number, that is our root 7. So take a point at 0 and take the radius OE, and using the compass draw an arc. It will go and touch our number line. That particular location point is nothing but our root 7 location on the number line. So this is all for any irrational number we can find using this particular Pythagoras theorem format. So let's do one more irrational number representation of root 10. So the easiest way of writing root 10 is nothing but 9 plus 10, where 9 can be written as 3 square plus 1 square. So root 10 can be written as 3 square plus 1 square. So in x-axis let us take 3 units. So 1, 2, 3, and in y-axis 1 unit, which is nothing but our base here will be equal to 3, and our perpendicular or else our height will be equal to 1 unit, right? And this point, let it be A, this point to be O, then our OA is nothing but root 10. So take O to be our position center and take OA to be the radius, and then mark an arc using the compass. It go and touch the number line at point B, which is nothing but the location of our root 10 on the number line. So using this particular Pythagoras theorem and converting our any irrational number to easiest form of part, then it will be easy for us to locate or represent any irrational number on the number line. Thank you.